Hello, Joe Neville here. Welcome to EVPN Config Snippets Part 1. So the agenda today is we are going to configure an EVPN VXLAN network on HPE Aruba Networking 6300s. I've got a couple in my lab at home, so I'm going to build up a network and we're going to do a bit of troubleshooting. Now, there's a lot of tutorials about EVPN VXLAN, but not much of a focus on troubleshooting. So that's what I'm going to do today. It's just going to be some pretty quick and dirty stuff, but I think it may be useful for some people. And also I just wanted to make a bit more content because lots of people have said to me over the last couple of years to keep producing videos. So this is an attempt to do so. Okay, right, here is our network. So there's a lot on here. Let me bring up a what we got, a laser pointer. These are 6300s. They're the standard ones that I've got in my home lab that I've made a lot of videos around. And what we're going to do is they're directly connected just back to back. So it's pretty simple. And then I'm going to configure this IP network between them. So that's a 192.168.0.0/31. I'm going to run OSPF between it so that we can propagate these loopbacks, because these are going to be the source and destination for our VXLAN tunnel across here. And then for the customer side, so the useful stuff, we are going to configure, so it's VLAN 10. I've got a couple of servers, got server 1 here, server 2 over here, and they are in the same subnet, both on VLAN 10, of course. And we are going to configure this here. We've got so it's the Anycast active gateway, so the distributed active gateway functionality that we have available on AOS-CX, so that the devices here, they both have the same default gateway of 10.99.10.1, which is here, and it's over here. And also we are going to configure the different IP addresses for the SVI. So VLAN 10 is going to be .11 here and .12 here. Like I said, there's a lot going on in this diagram, but we will build this up in part. Now CX2 is already configured, and I am going to configure CX1 and get this to ping across here. And then we're going to have a look at some troubleshooting. So I'll put a timestamp where the troubleshooting part starts if you're more interested in that. But building the config up, I'll be doing some show commands that I use as we go. Let's crack on with the configuration then. I will configure up here on the top part of the screen, and I'll keep this diagram as a reminder at the bottom of the screen as we go. Everything is physically connected. So I've got these two servers. These are just two Linux servers that we're going to be using as our example clients. CX2 is fully configured. CX1 has got a basic configuration on it, and we are going to build up the configuration on there and then do some troubleshooting. So these are both 6300s running a very recent version of AOS-CX. Let's have a look at a show version. Here we are. Okay, so it's 10.15.0.0.5, so that's a recent release of code. Now, let's show you the configuration on CX1. I'm only going to be able to show so much at any one time because I want to keep this diagram as a prompt there for you and for me as we go, because I'm just going to do all of this from memory. Okay, so not much on there. As you can see, pretty basic config. We don't even have those IP addresses, so I've got quite a bit of configuration work to do. Let us start with, so this is going to be my LAN. This is my LAN side configuration, and that is going to be an interface which is a VLAN access, and it is going to be in VLAN 10, as you can see VLAN 10 there. Okay, now we need the configuration. This is just a routed point-to-point link that connects between CX1 and CX2. So that's 1/1/2. I'll give that an IP address in that /31. Okay, there we go. Oh, it's not L3, right. I defaulted it actually. So they come up as a L2 by default. Let's make that an L3 with routing. Up arrow, put that in. Okay, so what else do I need? I need to add in this loopback. So the loopback is the source and destination for the VXLAN tunnel. So I'll give that an IP address. Say I'm doing this from memory, and also because I'm using loopback, so the devices do not have an interface that's directly connected between them for, it will be the BGP and for the VXLAN, because I'm using loopbacks for this. That means I need some way of CX1 knowing about CX2's loopback. It doesn't necessarily know about this 172.16.02 over here, so we use an IGP for that. I'm going to use OSPF 0, create area 0 there. Router ID 172. This is why I did the loopback first. Now we go back to the loopback, put that into OSPF. Very nice. And this interface one, same again. And also I'm going to use my network type of point-to-point, just so that we don't have that DR-BDR election where we have to wait for that. So point-to-point there, because it is a point-to-point network, and I think we are good. So we should be able to ping across that actually. If I go, okay, I can ping an IP OSPF. Let's jump over to the other side. I might not have point-to-point. Let's have a look. Or it could be MTU. Okay, which one's it going to be? I'll leave this in because it's good to see some troubleshooting, I think. So we've got X start there as a state, so I know that we're not fully configured. Right, now what, there we are. Okay, so we've got these, so we do have point-to-point on there. We've got PIM, this is just some remnants of some old configuration. It's the MTU that's stopping me going up there, the X start. Okay, so on this interface, let's up that. And IP MTU. Okay, so VXLAN, you want to increase the MTU to 50 bytes more than the external facing. So this interface here should be at least 50 bytes higher than here, which if we do that, come on, there we go. Yeah, now we're full IP over. Right, let's get rid of this one and we'll continue with CX1. There we can see, okay, so we've got the loopback for CX2. Now I'm going to go for the customer VLAN. So that VLAN 10, let's configure the SVI for that. So interface VLAN 10 and the IP address I've got in there. So this is the local SVI IP address, just a /24. There we are. And the configuration that I want actually, because we're using that distributed anycast gateway functionality, which allows our devices to just all have, regardless of where they are, which physical device they're connected to, they have the same default gateway MAC and IP address. So it's virtual MAC and virtual IP address. I'm going to configure that. Okay, so that is 10.99.10.1, and the MAC address I've just is, I think it is, just check that again. We'll have to copy that across. So VLAN 10. Okay, I've done it. One. There we are. Okay, do show run interface VLAN 10. Now, what else do we need? So I should, at this point, I should be able to ping 10.99.10.16. I can, good. Right, now the other stuff that we need to do then, because this is EVPN VXLAN, we need to configure our VXLAN, we need to configure the EVPN and our BGP. Right, I will go for, let's go for the BGP while I've got that in mind. So I know it's BGP 65001 is iBGP that we're configuring here. Router ID, which is the loopback, and then we need to create our neighbor 2, which is remote AS 5001, and we have to say the source for the TCP session. Okay, now for the address family, which is the L2 EVPN, the neighbor 72.16.02. We will activate it, and of course we need to send for the root targets. We have to send community both. Okay, all saved there. So that is the BGP. Let's have a quick look at show BGP. So the BGP address family for EVPN is this BGP L2 VPN EVPN. Let's have a look at a summary. We are established. Okay, fantastic stuff. Right, next up, VXLAN. I'm going to do the VXLAN interface. I always forget this bit, and this is one of the first times that I've ever not forgotten that. And that part we have to do the no shut. Okay, the VNI I've created is the 110. Well, it's not 110, is it? It's 10,010. Okay, so there we go. VNI VLAN 10. So that's the mapping there. So we're binding the customer side VLAN with a VNI, extending that broadcast domain. And then finally, I need to go for EVPN. So EVPN, we need to tell EVPN to record the MAC addresses that it sees on VLAN 10 and include those in the EVPN table. So we do that with this. We need to create a route distinguisher. I can go for auto because we're doing route targets and route distinguisher as auto. Everything's in the same AS, so you can just use auto for that for the route targets. If I keep hitting the wrong button. There we are. Fantastic. Okay, and right, I think I'll leave it there for now. Like I said, there's a little bit with the troubleshooting which I would like to show you. Okay, so at this stage, actually, I think, because I've got my BGP up, let's have a look at the BGP table here. So EVPN. Okay, what does that look like? Okay, we should see I've got my local now. Yeah, breaking this down then. So this is the EVPN BGP table. And here, one of the big things with EVPN is that you need to know BGP to start with. Okay, don't be like me in 2003 where I was trying to learn MPLS layer 3 VPNs before I actually knew BGP. Don't do that. Learn BGP first and then learn the address families of BGP. So your standard, setup is your IPv4 unicast address family, as it is nowadays, which always used to be the default one, if you go back 20 years. So learn the basics of BGP and then look at EVPN. That is the best way to do this, because so much of this, that's BGP, this over here with these metrics and these paths and things like that, that's all BGP. This is the extra stuff. So the route types, which is EVPN specific, and these rather attractive looking, of course, entries, they will make a lot more sense to you if you can read a standard IPv4 unicast BGP table. Right, but what do we have here? These are, you can see the route distinguisher. So the route distinguisher comes from the loopback because we're doing auto. So you can see there, .1, this is me. That 10 comes from the VLAN. Okay, so this route distinguisher, the auto, is made up of the local loopback and the local VLAN that we're using for this particular broadcast domain. So that's our route distinguisher. We know that this is locally injected, and you can see this is my local Anycast. So that's the active gateway. Now that's always injected into, I've just looked this up in the documentation. This is always injected into the EVPN BGP table. You can see the local next hop there. And what else do we have? So you can see I've recorded the MAC addresses. That's server 1. You can see server 1. That's a route type 2. So you've got the MAC address there, which is this one here. So DE94, and also the IP address. So that's a MAC and IP route type 2. There we are with .16. Route type 3s, I've done a long video on route type 3s. So that's essentially us saying, our local device saying it is interested in this specific broadcast domain, which is this VNI 10,010, and advertising that over to CX2. And on the CX2 side then, so that here you can see this has come from 172.16.02.10. We can see the different next hop. This is coming from our neighbor here. And what do we have? We've got route type 2s for the local Anycast SVI. Like I said, that's automatically injected into the BGP table. We've also got so this is our route type 2, just the Mac version of that for this server 2 here. So 59A6, you can see that. We don't have the Mac and IP, so we don't see 17 at the moment. But that's nothing to worry about, because essentially the devices, unless you send traffic that's going to go from CX2 out to 17 or CX1 to directly to 17, then it won't be in the ARP cache, it will be in the L2 cache. Okay, now that's kind of like doing a bit of troubleshooting. So let's go back to the presentation. Now I've done this configuration, I will save that off. So let's talk a bit about the tables that you can use for some EVPN troubleshooting. Here's our network diagram again then. Now with EVPN VXLAN, this is, well, it's in the name that it is a protocol stack. It's two protocols, VXLAN and EVPN, working together, control plane and data plane. But there's other processes that are involved here as well. Like if you read the RFCs for EVPN, it talks about local learning and remote learning. Local learning is essentially just flood and learn, like data plane learning. And then remote learning is where we're using EVPN to send updates about the MAC addresses and the IP addresses that we've learned on our local network. And so when we approach troubleshooting to say, okay, can we see a device, or where can we ping or can we not ping, one of the approaches that you can take is to step through the different tables to see whether they are populated as we would expect. Now, what do I mean by that? Well, here's an approach that I like to take. So first of all, what we have is, I've mentioned data plane learning. If we want to know whether a client is live on the network at layer 2, what table would we look at? So the flood and learn, so the data plane learning table of one of our devices is the layer 2 MAC address table. This is where the device records the MAC addresses, so the source MAC addresses of devices that it has received frames from. That's the first table. Before anything else, if a client is local and you want to know whether it's live, this would be the table to look in. This is a really standard L2 table, but it's been repurposed for EVPN VXLAN. So it's, even though, you know, people talk about like, oh, this great technology and all these things, you know, that you can do with this and all the different features and the functionality here, one of the most basic tables that I look at is the standard old L2 table, because essentially VXLAN is an L2 bridging technology. This is going to provide the information for you. Don't worry, well, I'll show you some more about this in a moment. This is a bit of a quick and dirty video. I've got much more about this, which I will record at a later date. Look out for that. Okay, so the L2 table, once we have the MAC address in the L2 table, as long as EVPN is turned on, as long as it's active on that VLAN, it will be passed to the EVPN table. So that's the next table to look at. So that's the EVPN MAC and IP table. And if everything's good, if everything's configured, that information, that MAC, so it could be MAC only or it could be MAC and IP, that will be passed to the BGP EVPN address family. So that will be populated. So that's the BGP address family part of this. The MAC address will be populated there. And from there, what we'll do, if we've got EVPN neighbors, we will create a route type 2 about that information. So this is where we create route type 2 to send the specially adapted BGP update to our BGP peers. And that will be imported, as you can see, like it, it's like though when you're doing networking, you learn about encapsulation and decapsulation at the different levels of the OSI. So we've got let's do my laser pointer here. You've got step 1, This is where the MAC address will be to start with, then the EVPN table, then the BGP table. From the BGP table, we create the root type 2s. That goes off to our peers. Where does that go into? It goes into their BGP table, then to the EVPN table, and then finally you'll see it in the L2 MAC address table. So from CX1, when we've learned a MAC address there, it will go MAC table, EVPN table, BGP table, create a root type 2, which will be imported into the BGP table, the EVPN table, and then finally the L2 MAC address table. So this is for L2 switching with an L2 VNI. If you've got IP as well, if you've got ARP involved in this, you will also see an entry go into the ARP table, so that will be shared. But for the purposes of this first pass, let's just have a look at this MAC table, EVPN and BGP table. Okay, so what would this be? This is local learning. This will all happen local to the box. It doesn't need to receive any BGP updates. And this part of it, so imagine if this is CX1, if you're looking at the point of view of the local device, this is all local learning. And then on a remote device, this will happen for a MAC address as remote learning. And of course, MAC addresses that are local to a remote device, we can reverse it. So this would be local learning that then goes over to remote learning in this reverse order. Okay, so what are the commands for these specific tables then? So I've included those. The L2 MAC address table on CX, what we do is a show MAC address table. It's as simple as that. The EVPN MAC IP table is a show EVPN MAC-IP. And then finally, that BGP EVPN address family is a show BGP L2 VPN EVPN. That will bring up the BGP update entries that we have local to our device. Here's our network again. So let's jump back onto CX1 that I've just configured, and we'll step through those tables and see the outputs of those show commands to prove, that this is what we can see here. Okay, back on CX1 then, I'll look at the show MAC address table. Will we see DE94? We do. Okay, here is the output. So this is my server 1. It's a local Linux server that I have. I think that is just a Raspberry Pi 5. Okay, so it's on port 1/1/1. There you can see the port dynamically learnt, which means we learnt this through receiving frames local from that server, and you can see the MAC address there. So there's the MAC address. Let's follow this through to the next table then. So there's show EVPN table, MAC and IP. And first of all, I'm looking for this DE94. There you can see DE94 in the EVI of 10,010. So that's our VNI. And on this MAC only entry, you can see the flag here. So this is useful because that shows you it's locally learned. We've learned that from a frame coming in on port 1/1/1. So no EVPN needs to be involved in that to populate this table, just this locally learned. It's come from here, but we have the EVPN VXLAN. So the reason why we're populating this, because if you think this table would have been populated anyway, even if we don't configure EVPN VXLAN. So if we do a show run, it's this command here, the EVPN VXLAN 10. That's the reason why we have that entry being passed here. Okay, now we have heard, because we are the default gateway, so we participate in that broadcast domain on CX1. We have an IP address there, and so we do pick up the IP address. I've obviously pinged that there. We can ping like this, 99.10.16, as we've already done. Okay, and what that means as well, so we will have a MAC and an IP address locally learnt for that, and we will see it in our ARP table. There we go. So you do have an ARP table. Now, because this is just an L2 VNI here, the device, if you don't have an IP address, it will just, so CX1 could just act like an L2 bridge for this broadcast domain. Okay, that's why I'm saying when you're doing the troubleshooting, I'm focusing more on just the fact that it's just the L2 for my methodology. You don't need to have that IP address in there, but because we can see it in the ARP table there. Okay, so we've done our show MAC address table. We've also done our show EVPN MAC and IP, and we can see server 1 there being locally learnt. And then finally, we've already done this, but let's bring it up again. So show BGP, L2, VPN, EVPN. You can see that entry is passed there, but it's all local. Okay, so the next hop is the local device. We've populated, so the EVPN table has populated the BGP, L2 VPN, EVPN. Right, now the other side of this then, so this is the local side, is of course the remote side. Now, do we have entries for what, let's do that in the reverse then. So I'm going to go for, we've already got it up on the screen. So it's the BGP L2 VPN EVPN. Do I have that for .17 and it's this 59A6? Okay, I don't. So I've got the L2. Like I said, this isn't a problem. Because we haven't done a ping to 17, so CX2 or CX1 hasn't pinged that. These devices, so CX1 and CX2, they can just act like L2. And to prove that, what I'll do is let me jump onto, let's get this a bit bigger. I'm going to jump onto server 1 and do a ping across. Okay, so right, this is just on my local management. This is server 1. I'll show you IP address. Okay, so this is server 1, and as you can see there, it's the 10.99.10.16, and there is the MAC address there, so it's the 1BDE94 as we have listed there. Okay, now from here, because this is in the same broadcast domain, we should be able to ping .17, which would mean that we've got the end-to-end. Okay, so if we go ping 10.99.10.17, we'll do the ping. Right, that is successful. And in the ARP cache, we can see .17 there, and you've got the full entry. Okay, so there's the MAC and the IP entry for .17. Now, if we look back on CX1, I don't think I'm going to have anything extra, and I don't, okay? I don't have a MAC and IP because it's this broadcast domain and we are acting like L2 devices for our customer side network. We're just acting at L2, so CX2 hasn't even got the ARP for .17 in there. Really, just at the L2 level, you just need the MAC address. Now, we can see that this is successful, so all good, right? Okay, so let's have a look at that BGP table again, and I'll just bring that up. So we're looking at this route type 2, and we'll step through the information that we can see. Now, this is on CX1, so through the troubleshooting steps on CX2, from CX2's point of view, it would be into the L2 table first, then the EVPN table, then its BGP table, and we are receiving a route type 2 from CX2, which is then going into the BGP table of CX1. And here is that entry for server 2. Now you can see it's a route type 2 there in the square brackets. You can see it is learned from iBGP, that's the I there. It's valid and best, great. The next hop is .2 there. Attributes are all defaults. You can look in more detail at this entry, but it's really quite a tricky command. So it's this command, and then what you have to do is you have to put the route distinguisher in, hyphen, and then the full entry from the route type onwards. If we do that, I need that square bracket at the end, there we go. Okay, so if I do that, there it is, there's my full entry, okay? So it's the route distinguisher, hyphen, and then the full entry. And that gives us more information of the individual BGP update. Same information that we've already seen, but there's a little bit more, like you get the extended community in there. It's just the more verbose version of this. Okay, that's the BGP entry for server 2. So let's look at what was the next one. If we're doing it in reverse, so it's the BGP, then it's the EVPN. So if we go EVPN, MAC, IP, there you can see, so it's V959A6, so it's this one here. Okay, that's the entry that's populated because we've remotely learned with a root type 2. We've got it in our BGP table and we've imported it into our EVPN table. So you can see that MAC address. You see, interestingly there, I think the next hop is the VXLAN. So that's the virtual interface VXLAN 1 with the underlay next hop of .2, and you've got that flag there, you know, making it pretty unambiguous. What's going on here is that this was remotely learnt, so this is a really useful table to see whether you've got entries. And then finally, that final table is that show MAC address. So the humble show MAC address table, which you can see the MAC in there, learnt via EVPN, and we've got the next hop, so that tells us the other end of the VXLAN tunnel. And to emphasize that point about the ARP table, so we don't have an ARP, we do for 16, but we don't for 17, because we're just acting at L2 for this, switching that broadcast domain, taking the traffic that comes in on that .1Q VLAN 10 locally, switching that to the VNI. So we can participate, and I can easily change that by doing a ping. So if I do a ping for, because we participate in that broadcast domain with an SVI, I can do this. So I should be able to pick there, and I can ping 17. Now if I look, let's do the ARP cache again, you'll see 17. And look, it's been populated across the, rather than a physical port, it's from this virtual interface, so the VXLAN 1 with the IP address. Here's our network diagram then, and that process was that we configured EVPN VXLAN on CX1. It was already configured on CX2, and those troubleshooting steps were that the MAC address here will be locally learned. If this device sends any frames that are received on the local physical interface, they will be stored in the show MAC address table, so you can check there first. If you've got EVPN, because this will happen regardless, this is just basic switch L2 bridging operation. If you have EVPN on that VLAN, then those locally learnt MAC addresses will be passed to the EVPN MAC IP, and from there, as long as you've got your BGP, L2, VPN, EVPN all configured correctly, the MAC and the IP entries here will be passed to the BGP table, which will create a root type 2. If you're doing an L2 only, it will be a MAC. If you've got an IP address in that broadcast domain and you've got an ARP table entry, that will be a MAC and IP. That will be sent over to, in this case, it would be CX2. So that RT2 will go into the BGP table. Then you've got the EVPN table, and then finally you've got the show MAC address table for remote learning. So depending on your point of view, if the client is local, then I would be using this process. So for server 1 on CX1, because it's all about point of view, okay? So if it's server 1 on CX1, I would be looking at the MAC table, EVPN table, and then the BGP table. If we were on CX1 and we were looking for server 2, I would be looking at the BGP table, EVPN table, MAC address table to see if I could ping across. So those three tables really give you some great insight into what's happening with EVPN. But depending on the point of view, depending on the process, keep that in mind, whether it's local learning or remote learning, in what table you want to look at first. I had a query about how to, and this is where the idea for this video has come from, had a query last week about how, if we were sat on server 1 and we were trying to get to server 2 and we weren't sure where it was failing or if it was successful, as I've mentioned, I would use these show tables. If I was on CX1 and I was querying server 2, does that exist? Is it live on the network? I would be looking in the BGP table, because this would be remote learning. So I'd be looking in the BGP table first, the EVPN table, and the MAC table. And if I was doing a ping, you know, side note, you can't use the active gateway to really test whether you can get across the VXLAN EVPN network here, because the active gateway is the same locally and remotely. So that doesn't really give us very much. That's why I've got the different SVIs in VLAN 10. So I've got .11 here and .12 here. So if I'm sat on server 1, I would try to ping my local gateway with .11 rather than the active gateway. Of course, check the active gateway is live, but from server 1, I'd ping .11, then I would ping .12, and then finally I'd try to ping .17 if I was doing a very methodical stepping through the network. And then to just show that, because I said to somebody that I would do this, I'm on server 1 here, and so I'm going through the pings that I would do is I would ping the local SVI first. I am on this server. I want to ping in VLAN 10, I'm going to ping this .11. So ping 10.99, 10.11. Okay, that's good. Now I would ping .12 and that would tell me that I can get across the VXLAN network. So .12, and I can see that is successful. And then finally 17. Now if I look in my server ARP cache, I should have all of those. Yeah, of course. There we go. I've got 17, 11, and I've got 12 there. Okay, so that was EVPN config snippets part 1. To be honest, I don't have a subject for part 2 in mind. So if you liked this, please give me a like, leave a comment, and I'll see about creating some more of these shorter videos to try to address queries and all those good things. That's it for now though. Thank you very much for watching. My name is Joe Neville, and goodbye.